So, as I said earlier, the reason why people use decimals rather than fractions is because it's much easier to compute with decimals, which is why calculators predominantly work with decimals and computers predominantly work with decimals. You can write calculators and computers that do work with fractions, but it is harder and they're more expensive, and you still lose the benefits of using decimals, which is the fact that you can easily compare the decimals, and also if you're using them for a real purpose, it's a lot easier to work with a decimal number than it is to work with a fractional number. So let's talk about using a calculator with decimals, which you certainly can do for adding and subtracting. We showed you how to do that without a calculator, but you're just going to use a calculator. Of course, with multiplying, it's pretty straightforward also, and you guys probably have used this all the time. There are ways to multiply decimals just using long multiplication, which I can certainly show you, or you can look up a video. But the time when I think a lot of students get confused with using a calculator is two places. One is using division, and the other is when you have multiple steps. When you end up with, I often have students say, oh, there's this really long decimal that you get. So let's try some of those. Let's take a problem like, 8 divided by 17, which you will end up doing things like this later on in the in a few units from now. And you use a calculator, and let's see what you get. So we go in here and we get 8 divided by 17, and this is where a lot of students will go, oh my god, it's a really long decimal. And it is a fairly long decimal. 0.4705882353. It is probably a repeating decimal, although the calculator doesn't give you enough information to show where the repetition is. And this is a good place to say that this number has been rounded, right? 0.4705882353 is not exactly 8 divided by 17. It's not the exact decimal equivalent. To get the exact decimal equivalent, we would have to keep doing the division until we start getting repeating digits. And it's not clear how long that will take. So generally, when you use a decimal like this, you're going to be rounding it. And rounding is a pretty complicated topic, which the short answer about how, and oftentimes students say, how much do you round to? And the answer is it depends on what you're trying to measure. So let's take this number, and it also depends on what this number represents. So let's go back. I'll just write this number out, 0.4. Let me just write it down, 47058822353. And I'll just write it down here. So we're looking at 0.4, whoops, 0.47058823. So remember what these mean, right? We talked about this before. So this is the tenths place, or 1/10. So this means 4/10. This means 7/100. This means 0 thousandths. This means 5 10 thousandths. This means 8 100 thousandths. This means 8 millionths. This means 2 10 millionths. This means 5 100 millionths. And this means 3 billionths. So 3 billionths of something, right? So let's think about this for a second. Let's say these numbers were centimeters. So we want to know 8 centimeters divided by 17 centimeters. So a centimeter is about, more or less about that long. I'm just kind of estimating, right? So it's reasonable to talk about 4/10 of a centimeter. That would be about that. Okay, I can kind of draw that red line. And then 0 100ths of a centimeter. Well, 100th of a centimeter is going to be really little, so 0 100ths of a centimeter. But 5 thousandths of a centimeter? I mean, can you imagine breaking this blue line up into thousandths and figuring out what that was? So it might not be too useful to get to, 5 10 thousandths of a centimeter. It might not be that useful to get to the 10 thousandths place, depending on what you're measuring, right? If you're measuring something like a piece of wood because you're cutting it, you might be perfectly happy with even just rounding to the nearest centimeter, and you might be perfectly happy saying that this number is, well, you probably wouldn't be happy with that because that would be 1, right? But you would be pretty happy with rounding to the nearest tenth of a centimeter. If you rounded to the nearest tenth of a centimeter, that's that. Okay, it's not going to be 0.4, it's going to be 0.5 because the 7 says bump that up to a 5. So if I rounded to the nearest tenth, I would get 0.5 centimeters, which is probably pretty good if I were doing some sort of cutting with some wood or something like that. However, imagine if I were doing eye surgery on you, you wouldn't be very happy with a tenth of a centimeter. You might be happy with a hundredth of a centimeter, but I actually don't think so. I think you're going to want to get to about a thousandth of a centimeter. So if we round to the nearest thousandth of a centimeter, that's the third place, we have to look to the right, to the tenth centimeters, and that's a 5, and that tells us that this number is going to be 1. So rounding to the nearest thousandth would give us 0.471. So either of these answers is pretty good. This answer, if you were to write this down, is pretty bad because it's rounded or truncated to this, which I thought was the billionth place, and you're almost never going to need the billionth place. So this is just saying I'm going to go to what the calculator goes to, which isn't generally particularly useful as a final answer. So you're almost always going to want to round. Either it will make sense what to round to based on the problem, or the teacher will tell you round to the thousandth place or round to the tenth place or whatever. However, here's a really important thing. Let's say you were doing 8 divided by 17, and then you wanted to multiply that result by 3,000. Okay, so 8 divided by 17 times 3,000. If I do 8 divided by 17 and then say, okay, that's about 0.5, and then I multiply that by 3,000, let's see. So this is where the dot doesn't really work, right? So 0.5 times 3,000, I'm going to get 0.5, whoops, let me clear this. I'm going to get 0.5 times 3,000, which is 1,500. 1,500. Okay, that's pretty reasonable. So that's going to give me 1,500. If I use this estimate, this rounding, 0.471, so let's see, 0.471 times 3,000, I'm going to get, let's see, 0.47, whoops, got to clear that, sorry, there's a clear button, 0.471 times 3,000, and that's going to give me 1,413. That's really different. So which do you use? Well, this is more accurate, but the better thing to do would be to do the whole operation in the calculator, leaving the original 8 divided by 17 in there, and then rounding at the end. So if I do that, let's see, clear, 8 divided by 17 times 3,000. And I get 1,411.76, and probably I might round that I might round to the nearest place value, one's place value. So that gives me, so if I do this thing in a calculator, what did I get again? 1412, because I'm going to round up. 1412, which is the most accurate that I can get. So that's the best answer, right? So I didn't round until I got my final result, and then the final result is what I ended up rounding. So that's when you do multiple calculations. All right, so summary. Using a calculator seems pretty reasonable. Calculators round always when they're working with decimals and they're doing division, unless the result happens to be a terminating decimal, and that is less than the resolution of the calculator. So you have to decide how you're going to round. Generally, you leave the value in the calculator until you have finished doing all your computations, then you get your result, and then you round to whatever is the place value that is requested by the teacher or that makes sense for the problem. Okay, the other situation that might come up is you might do a problem like this, 26 divided by 39, right, 26 divided by 39, so let me put that into the calculator. 26 divided by 39, and I get 0.666666667, which, if you wrote that down as your answer, I would mark it wrong, because you should recognize that as one of the common fractions, which is, in fact, and I'll pause, yes, you're right, it is 2/3. So if you end up writing down, if you end up writing down 0.6666667, I will say, no, buddy, that's 2/3. Okay, it's pretty common, actually a really common mistake is for people to do something like this, 26 divided by 39, times 3,000, and then they get this for 26 divided by 39, they say, okay, that's 0.6, or if they know about rounding, they say that's 0.7, and then they do 0.7 times 3,000, and then they get a number that's completely off. I'll just show you the difference, right? So if I do the whole thing, 26 divided by 39 times 3,000, that's clear. So 26 divided by 39 times 3,000, I get 2,000. Okay, equals 2,000. If I get 26 divided by 39, 26 divided by 39, and I say, okay, equals, okay, I'm going to treat that as 0.7. 0.7 times 3,000, I get 2,100. You can see those are completely different. Now, if I turn this, if I said, okay, I know that 26 divided by 39 is 2/3, then I would be doing 2/3 times 3,000, and 2/3 of 3,000, 1/3 of 3,000 is 1,000, 2/3 is 2,000. So you can see that this is the best answer. This is not a good answer, and it would be marked wrong. So that sums up what I would need to say about using a calculator with decimals. Most people don't even think about that, right?